Let's talk about two of the remaining concepts which are very important under statistics called as variance and standard deviation. And again, this falls under the absolute measures of dispersion. So far in the previous recap, we have covered the range, we have covered the mean deviation, we have covered the coefficient of range. This is not required from the syllabus. And then this is the only topic that is pending. We'll cover in the future videos. But today we're going to talk about variance and standard deviation. Both are very closely related, and hence we're going to take it in the same episode or maybe in a couple of episodes, and let's see what we have. And like variability, right? When I was trying to talk about what is variability at a high level, I took an example. But in general, right, variability is everywhere. Like you can see it everywhere. Nothing is same. You don't eat at the same time. And I've gone through this article here. This is good for the extra reading. You can go through that. But if you see that, what pretty much it says is variability is a part of our life. We don't eat every day at the same time. There is always some variance in the time that we eat. It could be a small delta, but there is a time difference on when we eat. We don't get up every day exactly at the same time. We might get up at 6 o'clock or 7 o'clock, but every day it's not on the clock. It might be 7:02, 7:03, 6:55, stuff like that. We don't reach to work or college exactly the same time. We just reach plus or minus within the ballpark, stuff like that. Every day the weather is not the same. There is always a deviation in the weather, stuff like that. So on and so forth. So what we kind of conclude is variance and variability as such is a part of our life, and there is always going to be some deviation, so we cannot get rid of that. That's what we understand here. There's always going to be some variance or deviation in everything that we see, we feel, we do in everyday life, or we produce in terms of goods. But what is important is the delta or the deviation, or is the difference, is it within the acceptable range, or is it consistent, and it should not be too much out of the way. For example, let's say if our reporting time at college is say 7 o'clock, we might reach at 7:05 plus or minus 5 minutes, but that's the delta. It should not be like we should be reaching one day at 7:30, then we are reaching at 8 o'clock. So the delta is huge. So deviation and variation is always going to exist as long as it's within the defined tolerance band or tolerance level, and as long as it's consistent within that range, it should be okay. So I just want to make sure that I make that point and put it across. Or let's move on to understanding variance, which is the topic of this episode. Okay, and I'm going to just recap the example that I had built for explaining the mean absolute deviation. So if you have not seen my episode on the MAD or mean absolute deviation, I strongly recommend that you see that, because some of the steps I'll be skimming through, assuming that you have seen those steps here, and there'll be a strong reference to this. So it's better you watch this first and come back here. Okay, so I'm taking the same example on what we covered in the mean absolute deviation, where I have a sample of 8 values, and we can assume, and this was the exam problem, and we can assume these values are anything. Let's assume for the time being that it's the distances traveled from a starting point by, let's say, 8 people, or we traveled on 8 different days and stuff like that. Okay, however you want to calculate. And when we're trying to calculate the mean absolute deviation, or in other word, mean deviation, let me write it down. That's another thing I wanted to explain. Mean deviation about the mean, okay? About the mean, okay? And I kind of forgot to explain that in the last video, but it was interesting. I was having an afterthought. So what did we do in the mean deviation about the mean, or mean absolute deviation? First, we take the regular mean. If you take this in the exam, you'll get the question like, find the absolute deviation about the mean. Even this problem was like that. Find the mean deviation about mean for this set of values. So the way you can think about that as a clue in the exam is, first you find the regular mean. You start from the words on the extreme right and move this way. You start finding the regular mean. That is the first step. The regular arithmetic mean that we find, that's the first step. For example, if you see here, I've copied the same table, and this is the regular arithmetic mean that we have found, 9.5. And then the next step is you're going to find the deviation about this mean. That means whatever is the deviation of this values over here from this mean. So we are going to subtract each of this value, or we are going to subtract this mean from each of this value. So the clue on how to solve this problem is in the problem itself. So we're talking about mean deviation about mean. We find the mean first. Then we calculate the individual deviations or differences from the mean. This is what we have done here. If you see as a step 2, we calculate each distance, which is the x minus mu part, this is the mean part, or we can also call it as x bar. We calculate that. And then what we do is we again take the mean of all of this individual deviation. So in a way it is mean, like I said, we're taking a mean of a mean. So, but the way you do is you just break down the words. You take the mean as step 1, you take the individual deviation, and the last step you take the mean, that is the sum of all these deviations. So that way it will be easier for you to remember if you just do the play on these words and try to understand and relate what it means. So mean, deviation about mean. Take the mean, take the deviation, and again take the mean as a whole of these deviations. That's what it is. So just wanted to give you that trick in your head. Nevertheless, as a quick recap of mean deviation, what we did is we used to calculate the mean, and then when we calculate the differences, we used to get this negative value here. And one of the methods how to get rid of the negative value is to take the absolute values, simply ignore the negative sign, and then we can get the absolute values. That's what we did in the concept of mean deviation. Like for example, if you see over here, whatever is negative, if you see here, the two bars, the vertical bars are the absolute value. We just forcibly converted this negative value into positive by getting rid of the negative sign, and that's what we did. So that was a core step of the mean deviation. But there is another way also to look at the negative values and get rid of that. Taking an absolute value is only one way, and by this time it should be already flashing in your mind what is the best part of getting rid of. Let's say we have negative value 4. What is the best part of getting rid of this negative sign in addition to take the absolute value? The other method is taking the square. If you take the square of this value, you will get 4 into minus 4 into minus 4, you will get 16, and the value automatically disappears. And that's the whole concept of calculating the variance. So what the variance does is it takes the alternative method over here. So instead of taking the absolute value, it just takes the square of the differences, and all the remaining steps remain the same. All the remaining steps before this absolute value over here, this part remains the same, and the part after this also remains the same. The only difference is instead of taking the absolute value for the mean over here, for the mean deviation, you just take the squared values of the differences. For example, over here, if you see the individual deviations or differences, I'm getting negative values, and I'm going to just square each of this value like this, x minus u the whole square. If you see here the square, and automatically I'm going to get rid of the negative values, and I'm going to make each of this a positive value. So this is the only step, this whole thing that I'm going to highlight. This is the only step that is difference between the mean deviation steps and taking the variances. Instead of the absolute value, you just take the differences. And then what you do is you just add up all of this. You just add up all of this values, just like how you did in the mean deviation. You just add up all of this. If you see here, this 190 is the addition of all these values. And then you divide by the given number of observations of frequency, which is 8. We have got 8 frequencies, right? We have the n is equal to 8. If you see here, and that's what you did. You take the numerator, which is this 190 over here, and then divide it by n, which is 8, and then you get this value as the answer is 23.75, and that's your final answer. And that's how you calculate variance. Okay, so variance, in essence, the whole unit of variance, this value, this particular symbol is called as sigma, and variance is, it's a square unit, right? So it's variance is expressed as sigma square. So variance is always expressed in terms of square units. So if your incoming units are, say, heights in terms of centimeter, variance is going to be centimeter square. If your incoming unit for values is age, let's say all of this are age, then variance is going to be an age square. And that's one of the problems of the variance. It helps solve the problem, but since it's a square, the units also get squared, and it does not make sense. For example, what do you even mean by age square? Centimeter square might make sense. You might say it's an area, but what do you mean by even 8 square? It does not really make sense. That's one of the problems, and then we will see that how we solve that problem when we cover the standard deviation. But summing up, variance, for calculating variance, you exactly follow all the steps like you're following for calculating mean deviation, except for this step 3, where instead of taking the absolute value, you're just squaring the differences and then hence making them all positive. And in terms of formula, this is how it is represented, where you It's same as the mean. Only thing is you don't have to put the braces over here or the vertical bars for the absolute value. You don't have to put this. You just put the regular braces to square and put a sigma. Remember, this is also called as sigma in Greek, and this is also called as sigma in Greek. This is what I figured out just now. But the only difference is in Greek, this represents an uppercase letter, that is a capital letter. In Greek, this represents a lowercase letter. So don't get confused if I'm using the word sigma for both of them. In this case, it means summation. You add up all this thing. And in this case, a sigma square is a variance. And only sigma is a standard deviation. We'll cover that in the next video. So if you see the formula, it's exactly like the mean. You take the differences, you square them up, you take the summation of all the values, and then you divide by the total number of observations. And just remember, what you're going to get is the square of the unit. So it's a variance is a squared difference, right? So variance is going to be sigma square. So don't forget that, okay? It's always going to be in the square. See, I've mentioned here, lowercase Greek letter, sigma for variance. It's going to be in a squared format because we are squaring the difference. So that's going to be the most important thing that you need to remember. And with that, it's a wrap up on how to calculate variance. Like I said, if you understand mean absolute deviation, calculating variance is not difficult because it's just one step different and remaining is the same. The only question that should come to your mind that I'm going to put in a separate video for all the curious folks, not for the folks who are just focused on the exam, but just people who are curious, for them some brain teasers, is why should even we take this approach of method 2 of squaring the differences? Why can't we just stick to the mean deviation format where we take the absolute values? What is the problem with that? Where exactly we need to use variance versus mean deviation? So what are the kind of reasons behind that? I'll try to put a separate video for the curious folks, but again, not related for the exam. So as such, that will be a wrap up on variance, and I'll see you in the next episode.